Alright, so in this problem, I have m to the power of 9 plus m to the power of 6 is equal to 36. So in the first, we write m to the power of 9 as m to the power of 3 to the power of 3. And then we write m to the power of 6 as m to the power of 3 to the power of 2. And this is equal to 36. Now, I'm going to let m to the power of 3 equal to the variable t. So now I have t to the power of 3 plus t squared is equal to 36. Now, if I subtract 36 on both sides, these two cancel out, and now I have t to the power of 3 plus t squared minus 36 is equal to 0. So now to solve this, I'm just going to start, I actually need to find one value of t to find the rest. So to do that, I'm just going to start plugging in values. So if I plugged in 0 here, that would just be negative 36. If I plugged in 1, that wouldn't work. 2, that would be 2 to the power of 3, which is 8, plus 2 squared, which is 4, minus 36, which would not work. 3, that would be 27 plus 9 minus 36, which would work because 27 plus 9 is 36. So I have 36 minus 36 is 0, which is right. So t equals 3. That's the value. That's one value of t. So now that we have that value, we can find the rest of the values. So what I'm going to do is, from here, I'm going to rewrite this as t to the power of 3 minus 3t squared plus 4t squared minus 36 is equal to 0. And now, if I factor out t squared from t to the power of 3 minus 3t squared, I get t squared times t minus 3 plus, now I have 4 times t squared minus 9. Now, this is the same thing as t squared times t minus 3 plus 4 times t plus 3 times t minus 3 is equal to 0. Now, if I factor out t minus 3, I get t minus 3 times t squared plus 4t plus 12 is equal to 0. So now this gives me two equations. I have t minus 3 is equal to 0, meaning t is 3, and t squared plus 4t plus 12 is equal to 0. And this is actually going to be result in no solutions. So t equals 3 is my only value. And remember how we set m to the power of 3 equal t. So if m to the power of 3 is equal to 3, this means that m is equal to the cube root of 3. Alright, so in this problem, I have x to the power of 2 over 3 is equal to 16. So I obviously want to find the value of x here. So for my solution, I'm going to rewrite this. I'm actually going to take the power of 3 over 2 on both sides. And the reason I did this was because if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n, right? And we want to find a value that when multiplied by 2 over 3 is equal to 1, because we obviously just want to find the value of x, and x is the same thing as x to the power of 1. So we want to make this 2 over 3 into a 1, and to do that, we need to multiply it with another number to make it 1. So that's why I multiplied with 3 over 2, because if you multiply 2 over 3, 3 over 2, these two are reciprocals, so they make 1. So now, because if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n, x to the power of 2 over 3 to the power of 3 over 2, that's x to the power of 2 over 3 times 3 over 2, which is simply 1, and this is equal to 16 to the power of 3 over 2. So I have x equals 16 to the power of 3 over 2, and we actually have to simplify this a little bit. So 16 to the power of 3 over 2, well, 16 is the same thing as 4 squared. So now I have 4 squared to the power of 3 over 2. And remember, if I have something in the form a to the power of m to the power of n, that's equal to a to the power of m times n. So this is equal to 4 to the power of 2 times 3 over 2. Now these 2's can simply cancel out. So now I have x is equal to 4 to the power of 3. Now 4, that's the same thing as 2 squared. So now I have x is equal to 2 squared to the power of 3. 2 to the power of 3, or sorry, 2 times 3 is 6. So I have x is equal to 2 to the power of 6. And this is the same thing as 2 to the power of 3 squared, right? 2 to the power of 3 is 8. So now I have 8 squared, which is equal to 64. So x is equal to 64. And that is my answer. Alright, so in this problem, I have x plus 100 squared is equal to 2x plus 199. So to solve this, I'm going to first start by rewriting 199 here as 200 minus 1. So now I have x plus 100 squared is equal to 2x plus 200 minus 1. Now from here, I can factor out 2 from 2x plus 200. So now I have 2 times x plus 100 minus 1. Now I'm going to let the variable a equal x plus 100. So now if I substitute in a for x plus 100, well, we have x plus 100 over here and x plus 100 over here. So now I have a squared. I'm simply just substituting in a for x plus 100 is equal to 2 times a minus 1. And this is the same thing as a squared is equal to 2a minus 1. Now, I'm going to go ahead and subtract 2a and add 1 on both sides. So these two cancel out, these two cancel out. And now I'll be left with a squared minus 2a plus 1 is equal to 0. Now a squared minus 2a plus 1, that's the same thing as a minus 1 squared. So this is equal to 0. And now if I take the square root on both sides, square root of a minus 1 squared, that's simply a minus 1, and the square root of 0 is 0. So I have a minus 1 is equal to 0, and if I add 1 on both sides, I get a is equal to 1. Now remember how we set a equal to x plus 100, so this means that 1 is equal to x plus 100, and x is equal to negative 99. So now to check, if I plug in negative 99 into my original equation, I get negative 99 plus 100 squared is equal to 2 times negative 99 plus 199. So negative 99 plus 100 is 1. 1 squared is 1. So I have 1 is equal to 2 times negative 99, which is negative 198 plus 199. And 199 minus 198 is simply 1. So I get 1 is equal to 1. And because this is correct, my solution is correct.